What we're going to look at is a solution to a specific problem. We're going to solve this specific type of equation. A sin x plus b cos x equals a constant. Now, if that constant's equal to 0, easy. Because I'll just move the cos x to one side, divide by cos x, and it becomes tan x equals something. But when I've got a constant number there, I can't do that. Two ways. One way is to use our t results, and what we do is we turn our trig equation into a polynomial, or a quadratic it actually end up being. So let's have a look at one. 3 cos theta plus 4 sin theta equals 2. Sub in the t result, so I'm going to let t equal tan theta on 2. Now, the denominator is 1 plus t squared in both sin and cos, which is convenient. So we'll multiply that out, and we get our quadratic result. 5t squared minus 8t minus 1. What is important is over here. Because I'm using the t results, remember, we're looking for answers for theta between 0 and 360. Which means when I'm using the t results, I'm only looking for answers for theta on 2 between 0 and 180. So I'm only looking for first and second quadrant answers when I use the t results. So 5t squared minus 8t minus 1, well, yeah, it doesn't factorise nicely. So 8 plus or minus root 84. So either t, which is tan theta on 2, is 4 minus root 21 on 5, or it's 4 plus root 21 on 5. 4 minus the square root of 21, positive or negative? Negative. So I know I'm in the second quadrant, and the second quadrant only. Well, we're only going between 0 and 180. So I'm looking for the obtuse angle answer to this. All right. Well, the acute angle turns out to be 6 degrees 39. So the obtuse one is 173.21. But remember, that's theta on 2. Multiply it by 2, we get our answer for theta. Okay, let's have a look at the other one. This one might be a little bit easier. 4 plus root 21, positive or negative? Okay. So this one is just in the first quadrant. So I'm looking for the acute answer. Theta on 2 will be 59 degrees 47. Double it, I get my second answer. So my two answers to this equation, theta is 119.33. Theta is 346.42. However, one thing we always have to do when using this method is we have to physically go and check whether 180 degrees is a solution. Why? Right. Remember, we're using t results. T is tan theta on 2. So it won't find the solution of 180 because theta on 2 would be 90 and tan 90 is undefined. So it won't find that solution. So let's have a look. Cos of 180, there you go, so we've got negative 3. Sine of 180, 0. So no, it's fine. It's not going to be a solution. And when you think about it, all we really have to look is the cosine, because it's always going to be sine theta and cos theta. Well, sine of 180 is 0. So really, we just have to look at the coefficient of the cosine function to see whether it's going to be a possibility or not. Okay. That's okay, that method. Personally, I prefer changing it into either a sine or a cosine function. It's what's sometimes called the auxiliary angle method, sometimes called the subsidiary angle method. I think I've seen it in some textbooks written like that. I'm going to change it into a sine function. Okay. Same equation. 3 cos theta plus 4 sin theta equals 2. Sine goes. Sine cos, cos sine. Thank you. So when I look at this, it's in the form something cos, something sine. Sine cos, cos sine. Well, if I've got the cos theta, 3 must somehow link with the sine alpha. And 4 must somehow link with the cos alpha. So what I can do is draw up a triangle. Well, if it must somehow link with sine alpha, I'll make the opposite side 3. So there it is. I'll put that over there. Cos alpha links with the 4, so I'll make the adjacent side 4. Bit of Pythagoras, we've got the hypotenuse. I can now change the answer. Now, I wouldn't normally write this step in, but it's just to highlight. Because obviously sine of alpha can't equal 3. If I look at my triangle, sine of alpha is actually 3/5. So I would have liked 3/5 there. Same with the 4. Cos alpha can't equal 4, but it can equal 4/5. So if I multiply by 5, then I've got 5 lots of 3/5 and 4/5. So what that always means is, whatever that hypotenuse ends up being, that's going to be the coefficient of the trig function. It's like that. I don't normally write that middle step in. I would just normally jump to, okay, I know it's going to be 5 times. I'm changing it to a sine function, and it was, well, alpha plus theta or theta plus alpha, whichever you prefer. How do I work out alpha? Well, I've got a triangle over here I can work out alpha from. Tan alpha is 3/4. So approximately 36 degrees 52. So I know that sine alpha plus theta is 2/5. It's either in the first or the second quadrant for this one. So the acute angle, which I'm now going to call beta, just give it another pronumeral, is 2/5. The acute angle is 23 degrees 35. So alpha plus theta is either 23/35 or 156/25. Subtract 36/52 and we get the same answers almost as before. But you'll notice I've got negative 13. I want answers between 0 and 360. Negative 13, no good. So all I do, add 360. So there's my answers. 119.33, add 360 to the negative 13.17, and I get my other answer, 346.43. Same answer as before. Now, I reckon that's a lot quicker. I've put a lot of extra steps in that I wouldn't normally write down, just to highlight how I'm doing it. Okay. Could have changed it to a cosine function if I wanted to. Let's do it. Same question. But this time, I would want it in the form cos, sine, sine. So the cosine, 3 must somehow relate to that. I'll make that the adjacent. Sine, opposite, I'll make that equal to 4. Once again, the hypotenuse is 5. So it's going to be 5 cos, but this time, if it's not the sine, it's not the sine. So it's theta minus alpha is equal to 2. Yeah. God. Okay, so once again, the hypotenuse becomes the coefficient of the trig function. Tan, this time is now 4/3, because I've got my sides the other way around. That angle is 53 degrees 8. First or the fourth quadrant. The acute angle for this one will be 66.25. So theta minus 53.8 is either 66.25 or 293.35. Add 53.8 to both, and there's our two answers. So let's have a look at this HSC one. Here, it wasn't actually an equation to solve, but they just want us to transform this into, and they're forcing our hand, they're telling us it has to be a sine function. All right. Root 3 sine 3t minus cos 3t. Okay. Now again, I wouldn't write that down, but in my head I'm thinking, okay, I want to change this to sine cos, cos sine. So there's the triangle, bang. The adjacent side will be root 3 because I want sine cos. So cos is associated with the root 3, adjacent is root 3. Cos sine, well in this case, well there's no number there, so it must have been a 1. So I put a 1 on the other side. Bit of Pythagoras is 2, so I now, there it is, 2 sine 3t minus alpha. Just got to work out what alpha is, of course. So I've worked out r. Alpha, oh, it's nice, it's an exact value, it's 30 degrees. There's the answer done. Mm-hmm. This one came from 2003. Okay. You'll notice in the HSC questions, they're not bringing up that problem. It's giving you the logical thing that you would do. So this time they said sine x minus cos x in the form r cos x plus alpha. In this case, that would make sense because you want sine cos, cos sine. If it's not the sine, it's not the sine. So sine x minus cos x. Again, I wouldn't write that down, but I'm thinking cos, cos, sine, sine. So in this case, look what I did. We see, look, they've said express sine x minus cos x. Okay. So my formula goes cos minus sine. It doesn't go sine minus cos. So I've made it look like what I want by factorising out -1. So I get minus cos x minus sine x. And the cos x minus sine x I can now change. Okay. Nowhere did they say r had to be positive. So now, well, it's 1, which makes that one root 2. So there we go. It's minus root 2 times the cos of x minus alpha. Alpha in this case, 45 degrees. There's the answer. All right. 2e. Oh.